And the very last thing is, now that we have these approximation methods, we can do something called a Riemann sum. It's just a fancy way of saying we're going to make as many rectangles as possible. All right, so we could have done all this in pre-calc of just kind of breaking our area under our curve into rectangles. But what we can do in calculus now is we can start making more and more rectangles. So we're going to take our curve. We're going to start off with like 3 rectangles, and then we're going to turn it into 6, and then more rectangles. All right, the more rectangles I add in here, the closer my approximation is going to be to the actual area. And this is going to be the limit. All right, so as my answers get closer and closer to the exact answer, the limit is going to be the actual exact answer. All right, the way we do this is by adding more and more rectangles. All right, but you can see if you have more rectangles, just do like this as an example. As I split these up into more rectangles, the width of them gets smaller. So every single time I add more rectangles, they get smaller width. So if I want to add an infinite number of rectangles to make it as accurate as possible, the width is going to break down and become 0. But a rectangle with width 0 has area 0, so then suddenly that doesn't work anymore. All right, and the idea again is having a limit. The area is not going to be, or the width's not going to be exactly 0. It's going to be going to 0. And this is where we get the definition of a Riemann sum. It's looks really complicated when you have all the notation and everything, but this is basically saying the exact area under the curve is the limit as we let n, the number of rectangles, go to infinity. So if we do this approximation and we figure out what's happening as we get an infinite number of rectangles, that's going to give us the exact area under the curve of f of x. So that's what you have to kind of remember for Riemann sums for right now, just knowing that it will actually end up giving the exact area when we get an infinite number of rectangles.